All right, on number 5, we're going to be finding the least common multiple, and the method they want us to use is dividing primes. All right, so I've seen it in the textbook, or we talked about it just a little bit. This one's a little bit different than I'm used to, but we'll show you how it works. And then they show you with 3, and so I'll just kind of go through what my understanding of it is. You're going to divide what they have in common. They both can be divided by 5, let's say. So divide by 5, we get 6. Divide by 5, we get 15. All right? Then we divide them again. And we can divide them by 3. And that will leave us with 2 and 5. All right. So when you get down to the point where they're both prime, if there were 3 numbers, I think you can continue to go as long as there's 2 numbers. I don't know if it works if there's only 1 number that can be reduced, but it would not change anything in this case. So you would continue dividing even if everything can't be divided. As long as something can be divided, you'll keep reducing. So 2 is even, so we can divide by 2. All right, that will leave us with a 1, and then you just bring the 5 down because you can't reduce that one. So in this case, I don't think it matters because 2 times 1 is still 2. But if you have more than 2 numbers, you can continue dividing even if everything can't be divided. And then at the end, you're just going to multiply all the numbers on the outside. So had I stopped at this step, I would have done 5, 3, 2, and 5. Okay. Which is going to get us the exact same thing because all we're doing is multiplying by 1. So 5, 3 times 2 times 1 times 5. So it doesn't change anything, but you do need to be aware that just because everything can't be divided, which is normal for math, with the least common multiple method, you can keep going. All right, so we get 15 and 10, which gives us 150. And the same thing, they both equal 150. So the least common multiple with the dividing method is going to be 150. All right, and then it says use the dividing method by dividing prime factors to find the least common multiple. Okay, so here's one with 3 terms, so we'll get to see that in action hopefully. Number 6, we have 16, 120, and 720, 792. Okay. All even, so let's divide by 2. That's easy to do. So that will give us 8, 60, divide by 2, 3, 1, 18, so 9, 18, 1, and 12 is 6. Okay, so let's divide them by 2. All even, so we can divide by 2 again. So that will give us 4. Divide by 2 is 30. Divide by 2 one time. 19, 9 times, give us 18, 116 is 8. All right, still all even. So we can do 2 again. Divide by 2, give us 2, give us 15. Divide by 2, that's almost times 200, so 99. All right, so here's that one where this one is even, but these 2 are not. These 2 numbers are divisible by 3. So from this step, we're going to divide by 3. This one cannot be divided by 3. We just bring it straight down. Divide by 3, we get 5. Divide by 3, we get 33. Okay, so now there is no number that will divide any 1 or any 2 of these. I mean, we could do, again, divide this one number by 3. Which I don't think it will change anything, but I just want to see that you get the same thing. So we'll do a 3 here, bring down the 2, bring down the 5, and then bring down 11. Okay, so now at this point, all of these are prime. So I'm going to look at it 2 different ways. I'm going to look at it at stopping here, okay, and just doing all of these numbers on the outside. And then the only thing that we did different was 3 times 11, which is still 33. So it should be the same. but you go as far as you can in this method. So we have 1, 2, 3, 4 2s. And then we have 2 3s. And then a 5. And then 11. So it's 1, 2, 3, 4, 5, 6, 7, 8 terms. 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay. And let's check that to stopping at this method. So we have 1, 2, 3, 4 2s, 3, 5, 33. So 4 2s, 3, 5, and 33. So you can see that's going to be the same because this 3 and 11 just combined to make that 33. And then everything else is the same. If you just kind of ignore that, you got 4 2s, 3 and 5. So they both work out the same way. But you just need to be aware of that, okay? This method is a little bit different. So let's multiply all this together. 1, 2, 3, 4 2s, 3, 3. And then 5, and then 11. 7,920. 7,920. Okay. So this is new, but I like it as well.